So, good afternoon, I guess. Today we're going to be looking at sets because I got a question in one of the comments to talk about sets. So I'm going to run through the basic knowledge of set notation that you should know. So we know that a set is a collection of elements. Now these elements can be anything. They can be numbers, letters, coordinates, but usually in math they are numbers. You could describe a set of a set by writing the elements in curly brackets. So 1, 2, 3, 4, and then okay, set notation. So the first thing you should know about set notation is this notation. It's kind of like an E, but it means the universal set, meaning the set that covers all the numbers. So if you had something like this and you had 2, and this was E and this was F, and inside E you had 6, 4, 2, inside F you had 1, 3, 9, and then outside here you had 5. Your universal set will be everything inside here. So it will be 1, 2, 3, 4, 5, 6, 9. So this is what your universal set looks like. It's more like I really don't know how to draw the notation. So yeah, that's what your universal set is. What else do you need to know? See, this means this is an empty set. So if you see this notation, it means there's really nothing inside. There's a set with no elements in it. If you see NA, it means the number of elements in set A. Number of elements in set A. So for example, with this example I gave before, if you had like n of E, the answer would be 3 because you have 3 elements in set E. Then now if you had n of an empty set, what do you think the answer will be? Because an empty set has no elements, so this will be 0. So this sign means is an element of. So if you had, say, the letter D, this A, this means D is an element of A. If you had this, like a C with an underline underneath, it looks like a C, but yeah, it means a subset of a subset. So if you had this A subset B, it means that every element in A is also in B. Usually you can see that as, if you want to visualize that, you can see that as 2 circles inside one another. So let's say this is your B, your A is inside your B. So every element inside here is also inside here. So A is a subset of B. If you have this, it means a proper subset. So this means that if you had something like this, A proper subset B, it means that A is a subset of B. A is a subset of B, but not the same as B. The difference would be, okay, you say what's the difference in this and this. So take, if you had like a less than or equals to sign and you had just a less than sign, these are not the same. So you can say if A was the set of 1, 2, 3, 4, and B was the set of 1, 2, 3, 4, 5, 10, 15, right? A is a subset of B because there's A inside B, but they are not both the same. So in this one you can say that, oh, if A was 1, 2, 3, 4, B is 1, 2, 3, 4. These are exactly the same, so you can say A is a subset of B. I mean, you rarely see cases like this, but that's how you differentiate both of them. So if you see this sign with an underline, like a C with an underline and a C without one, you know that the one without an underline is that, oh, A is inside B, but they are not exactly the same. So it's a very similar difference. So if you have a cross through all these, so remember that this E sign means is an element of. Now if you have a cross on it, it means is not an element. Same thing goes with this, is not a subset, or is not a proper subset. Okay, now let's get to the meat of this, of sets, the thing that you're going to see all the time. If you have that A needs B, this means that A is an intersection of B, meaning that, well, sorry, not A is an intersection of B, that whatever you're looking for should intersect A and B, yeah, meaning that they should overlap. The overlap of A and B. So if you had, usually you will visualize that as this, right? So this is the intersection, they overlap somewhere. This smiley face, as I like to call it, B, is the union of A and B with no repetition. I think sometimes people forget that they're not supposed to repeat. So if, like, say, let's take our example from before. If A was 1, 2, 3, 4, and B was, say, let's say 2, 3, 4, 5, 6. Now the union of A and B, A union B, as people call it, would be everything like this. Now note that some of these, they repeat. So the ones that repeat, just count them once. So this would be 1, 2, 3, 4, 5, 6. This is your union of A and B. Now, A complement can be written as this, or you can just write A complement. This means everything outside of A, or everything not in A. So if I'm taking this example from before, this A and B, if I said A complement, so which means everything that is not in A. And if I look at this is A, right? These three are in A, so I'm not counting them again. So which means A complement is 5 and 6. If I'm drawing it out, and I have this, right? And this is my A, this is my B. And I said I want to find A complement. So everything that is not in A. So this is A. This is A right here, right? Everything not in A will look like this. Now, not just this, but the outside too. The outside as well. So everything that is not inside A. Sorry. Yes, everything that is not inside A. So this is your A here. This circle. Everything not inside it is, well, not inside it. So I think that's all the notations you need to know. Now let's actually do some problems. It says in the Venn diagram, this is May June 24 math, May June 24 paper 2-1, just in case you want to reference it. Now it says question 16, in the Venn diagram shade the region M prime intersect N prime. Sorry, I said M prime, or M complement. It's the same thing. M complement intersect N complement. That's everything not in M intersecting with everything not in N. Now, this is your M, right? Everything not in M is, I'll do that in green, is this, plus your outside. Right? Now, this is your, what color should I use? Use a different color. Say blue. This is your N. Now, everything not in N, I'll do that in red. You have not in N plus this as well. Outside. Okay, now you're looking for where they intersect, where they overlap, the overlap of it. So in this case, that would be, oh, where do you see my red marks and my green marks? In the same place. This is, in this part here, this is only red, this is only green. Here you see red and green. So I'm going to take this away. So your intersect, your M complement intersect N complement will be outside, right here. I can use a highlighter to fill it in. Right here. Yeah. This is what it should look like. Now, this one you're going to want to take it bracket by bracket, like how you do your PEMDAS or PADMAS or whatever, brackets first anyways. So you take this inner bracket first. A complement union C. And let's break everything down. Well, first of all, what is A complement? What's the set of A complements? So A complement is everything not in A, like we've been saying. So everything not in A will be, this is your A. right? Everything not in it will be this, and outside, right? And what numbers are there? You have 3, 4, 9, and 20. Right? 3, 4, 9, and 20. Now, what is your C? Your C, this is your C. This is your C. So they are just asking what is C. So C is 9, 4, 18, and 10. Now A complement, union, C complement. Remember we said union is everything together with no repetition, right? So A complement union C. So everything together, that would be 3, 4, 9. Now 9 repeats, so just use one of 9. 4 repeats as well, so just use one of that. So 3, 4, 9, 10, 18, and 20. So 3, 4, 9, 10, 18, 20. These two repeat, so you don't need to write them twice. Now, that's your A. That's this right here. Right. Now, what is your B? Let's go. We're moving out. We're going in, out. What's your B? Your B is right here. So you have 3, 4, 10, and 16. Now the question says B intercept this whole thing. And we've already found this whole thing as one set. So where does B overlap this? Because remember, intercept means overlap. So where does B overlap? What numbers do you find in the overlap of B and A union C? Well, if so, we don't be calling, let's say this is D or something, right? This whole thing, as D is A union C. So where do you see the overlap of B and D? So that would be, let's look closely. 3 is here, 3 is also here. So this is 3, right? There's 3 there. 4 is here, 4 is also here. You have 4. 10 is here, 10 is also here. You have 10. And let's look at the other ones. This is 16. There's no 16 here. And if you go the other way, this is 9. There's no 9. This is 18. There's no 18. This is 20. There's no 20. So these are the only numbers that overlap between this B and A union C. A complement union C. Now remember I said that N, when you have N in front of it, you have, where is it? The number of elements in that set. So the number of elements in this set that you found is 3, which means here your answer is 3. Now there's a little contradiction, right? If we go to the mark scheme and check. But however, I believe that they did actually make a mistake in this, because they wrote 17 here. Now why I said they made a mistake is because instead of just counting the elements inside, they actually added it up, and you're not supposed to do that. So I am going to, yes, it's contradictory, but I'm going to stick with my answer, because these are the basic laws of sets that you can even go to your math teacher and ask him the same thing. These are the basic laws of sets. So it should be how many? Oh, this is 1, this is 2, this is 3, not the addition of it. So I believe that this answer here is supposed to be 3, not 17. Anyways, yeah, if you look at 16A, you got that outside, everything outside it. We did that right here, so this is fine. But like I said, I still believe that this is 3. You can, if you don't believe what I'm saying, you can actually go ahead and ask someone else. But the basic rules of sets do say that if you have n of A or n of A union B, it means the number of elements in that set, not the addition of elements. Okay, let's go do a different question. So this is still the same year, but paper 2-2. So May, June 24, paper 2-2. And we're going to work on number 7. Now it says, on the Venn diagram, shade the region A union B. Now remember we said union is everything inside with no repetition. So we're just going to say A union B is everything here. Everything inside here. Not counting the outside. Outside is not part of it. A union B is everything inside. So this is the only question on this page. If you look at here, this is the mark scheme for it. Everything inside A and B. Now this is the same here. I'm just doing different questions, different set questions on it. This is number 17. So here it says W is the students who walk to school. G is the students who wear glasses. Now there are 20 students in this class. 8 walk to school. 3 wear glasses and walk to school. 2 do not wear glasses and do not walk to school. And says complete the Venn diagram. So remember, this notation means your universal set. Your universal set is everything together, right? And we said W is people who walk to school, and G, people who wear glasses. Now, we're going to start from the bottom. It says 2 do not wear glasses and do not walk to school, meaning that these 2 are neither here, nor here, nor here. So which means these 2 are outside of the circle. These 2 are here because they don't walk to school. They are not part of this set. They don't wear glasses either. So basically what you have, this, if you want to write this in set notation, you would have W union G. That's the union of people who walk and wear glasses. Complement. That's everybody who walks and wears glasses together. Like everybody not in that set. Everybody not in the set of people who walk and wear glasses. So your 2 here is outside. Okay, that's the first part. Now it says here that 3 wear glasses and walk to school. So and in this case is they do both, right? So if you want to write this in set notation, you say W intercept G. So people who walk and wear glasses, they do both of them side by side. So where do you have W intercept G? Where do they overlap? That will be here in this case. So in this place, you're going to have your number 3. Right, now we have, remember we said there are 20 students total. We have 5 of those students. Now it says that 8 walk to school. So which means the entire set of W should be 8 elements. Yeah. Sorry. Not sure why I wrote that. W is 8 elements. The entire set of W is 8 elements. So we can't just go ahead and write 8 here. That would be wrong. Because if we now look at the entire set of 8, if you just write 8 there, the entire set of 8 now becomes 11. Of W, becomes 11. But they said only 8 people walk to school. So we are going to do a little algebra here. Where you have, so we're going to take this away. So if 8 people walk to school and 3 people, we know that 3 people are already in the set. What number will you have here that, this number of people work only. Usually in a set question, you will see when you see only, it means in this space, in this space here, when you see the term this only, or people wear glasses only, or people walk to school only, it means that in this white space alone, remove the intersection, or remove everything here, only is this portion. So only will be the total, right, minus the intersection. This is the total. This big circle is the total. So you're looking for only, right? And we don't know what that is. So we know that the total is 8. And we know that the intersection is 3. That's this place here is 3. 8 minus 3 is 5. Which means that only in this case, what we have in this portion here is 5. If you are not sure, always go back to the question and see it says 8 walk to school, meaning a total of 8 people walk to school. So if you should draw the set of just W, you should have a total of 8, and you have 5 and you have 3. So 5 plus 3 is 8. Right. Now that leaves us with G. What is here? How do we find out? They didn't give us any more information, but apparently we have all the information we need, because we know that the universal set is 20. That's the total number of students in class is 20. So you have 20. We're looking for G only, right? Usually you would say G only. How do I put this in notation? Okay, you'd say the G only. Just going to write it like that. So 20 minus 20 is the universal set. Remember this funny looking 3. I'll be E sign. So 20 is the universal set, and you subtract, or you everything here, add them up and subtract it from 20 to find what is left. So you have 2 plus 5 plus 3. 2 plus 5 plus 3 is 10, I believe. Yes. So this would be 20 minus 10, which is 10. So your G only, that means this space, your G only is 10. Right. So then, to always double check whether you've gotten all the information from the question, right, you would add all the numbers inside this set, and make sure it gives you 20. If it doesn't give you 20, then go back, something is wrong. So this 10 plus 3 plus 5 plus 2. 10 plus 3 is 13, plus 5 is 18, plus 2, 20. We have a total of 20. So diagram should be correct. Now go to mark scheme. Your mark scheme number, what number is that? Number 17. Oof. Did I? Okay, yes, I did. So look, they have here 5, 3, 10. 5 is W only, 3 is the intercept, 10 is G only, and 2 is outside. So here we have 5, 3, 10, and 2. So we got this question correct. Again, if you don't understand something, feel free to comment and let me know where you got confused. Okay, we're going to do one more question because I think we're running into 30 minutes now. Okay, last question. The Venn diagram shows the information about the number of students in a class. Some study English, which is E, English. Some study French. And some study Spanish. And some do not study any of these languages. So when you say some do not study any of these languages, that is outside all this. In this case, I'll be 5, meaning 5 people don't study anything. Okay, now it says find n. That's find the number of people E union F, not in E union F union S. I remember what I said, what we did before. You took it bracket by bracket, right? We're going to do this inner bracket first. So what is in E? Like the set of E is what? If you look here, the set of E is 1, 1, 2, 8. The set of F is this 1, 1, 3, 6. Now E union F, I'm taking it step by step. E union F is, remember, the union is everything to get in those two sets without repetition. You see a lot of numbers repeat here, so we can, this set is not going to be a big one. So 1 repeats, so you only need one of those 4 ones because there are way too many ones. So 1, 2, because this is your 2 here. 3, 6, and 8. So this is E, 3, 6, and 8. This is E union F, but it's asking for E union F complements. That's everything that is not in E union F. So everything not in E union F is just these two, 5 and 4. Because E union F is this entire thing here. This is E union F. What numbers can you notice that are not in this green highlighter that I just gave? That would be 5 and 4. So E union F is 5 and 4, right? Now, you got to one part of it. Now, they said you should union that with S. Now, what is S? I'm going to take away this highlighter. What is your S? Your S covers this whole thing. So your S is 1, 2, 3, 4. Alright. Now you want to find the union of this right here and this. So like I said, just join everything together, remove numbers that repeat, or not remove, only use one of the numbers that repeat. So union this is going to be 1, 2, 3, 4, because you have 1, 2, 3, 4. 4 repeats, so you don't need to write 4 again, and then 5. Now n, like I said before, is the number of elements. Now how many elements are in this little set here? 1, 2, 3, 4, 5. So the answer here should be 5. Like my argument before, when you look at the mark scheme, you would see that they added this together to give you what? 8, 10, 14, 15. However, I still believe that this is not the case. This should be 5. If you have a problem with that, if you go and ask somebody and they say the same thing that I'm saying, let me know in the comments. So that'll be all for today. Again, like this video and subscribe for more. Thank you.